Hello and welcome to this episode of SPSS one-on-one series with the word analytics. Today we interpret output of a Cox Proportional Hazards Model in SPSS. In our previous episode, we saw how to assess for assumptions of a Cox Proportional Hazards Model in SPSS. If you've not watched that video, I highly recommend that you go and watch it. So today we are going to briefly demonstrate how to run the Cox regression model and interpret the findings. This is our data set that we previously used to assess for assumptions of Cox pH model in SPSS, and these predicted residues were as a result of one of the procedures for assessing the assumptions. So we are going to do away with them. This is our variable, time of follow-up or time to event, and our event is recovery from a disease. We have got three variables that we want to use to explain survival time. So to fit a Cox pH model, simply go to Analyze, Survival, and then you select the Cox regression. You put the time variable in this time box. You also put the recovery or the status variable in the status event. Then you define the event, where I will say 1 denotes the event happening. Then continue. We put our explanatory variables in the covariates box, and then we specify which ones are categorical. All these three variables are categorical in nature, and we would like to use the first group as the reference group. So you select first and then click change, then click continue. And under options, you're going to check the box for confidence intervals for the exponents of beta, then click continue, then OK. So we shall have a case processing summary here that shows you how many events you have in the data set, how many are censored, and the total sample size that you have. Then you see any which have been dropped, probably because of missing names. Okay. It also shows you here that our dependent variable is time in months. Remember, in survival analysis, where we use the Cox pH model, we are looking at time to event or survival time as our outcome of interest. We also have here a table for categorical variable codings and the dummies that have been created. We have treatment group, where 1 is treatment A and 2 is treatment B. So SPSS is telling you the numbers in each group and which one is being used as the reference, then which one is being compared to that reference group. If you look at sex, for example, the females are being used as the reference group, and also the non-smokers here are being used as the reference group. Then we have here a table for omnibus test of model coefficients, which shows us the goodness of fit of our model. We also have a table for variables in the equation here. We saw the first table as omnibus test of model coefficients, which tests the goodness of fit for our model. If we have a p-value that is non-significant, the way we have it here, above 0.05, the usual alpha value, it is indicating that the variables did not make significant improvements in the model compared to the null model, the model without any variables. So this suggests that our model was not a very good fit for our data. We also have this table for variables in the equation. This table shows you the variables, the explanatory variables that you're trying to assess whether they have an effect on survival time. And we have 3 of them, which are categorical in nature here. We have group, we have sex, and we also have smoking status. So here you can see that we have the betas for each of the variables. And these betas are not interpreted directly, because actually these ones show changes in natural log of the hazard. But generally speaking, they can be interpreted this way. So positive coefficients indicates a positive relationship between the covariate and hazard for the event, i.e. higher values on the covariate are associated with the higher recovery time. Since our outcome of interest here is recovery. If, for example, it was this, then it would be associated with the higher survival time. We have here p-values that shows the significance for each of the betas for each variable that we are assessing, and we can see that all of them here are non-significant. Next, we have a column for exponents of beta, which in this case, exponent of beta is actually a hazard ratio. And a hazard ratio of 1 indicates that the variable does not influence recovery for our case. If it was an outcome like death, that would mean does not influence survival. Then if the hazard ratio is above 1, then subjects in exposed group have higher hazard than those in unexposed group. We just use the word exposed and unexposed to loosely refer to the groups of your independent variable. For example, we would be comparing people receiving treatment A versus those getting treatment B. Or we could be comparing males against females. Whereas on the other hand, if we have a hazard ratio less than 1, it shows that participants in one group have lower hazard than those in the other group. So how do we interpret these hazard ratios? Before we interpret these hazard ratios, we need to remember the categorical variable codings. What was coded with the lower code and which one had a higher code. And then for SPSS, which one is being given a 1 in its dummy variable. Here it is showing you that those with the zeros are the reference category. And how is it picking this? Remember, at some point in the setup of the analysis, we specified that we want the reference category to be the first one in the groups, among the groups of the independent variable, and we changed this to first. So that's why if we have the groups of treatment 1 and 2, we are using 1 as the reference category. That's why SPSS is giving it a 0 and then creating a dummy for treatment B as the one we are going to interpret compared to the reference category. Although these values are all non-significant, but we can go ahead and interpret what they mean if they were statistically significant. So let us interpret the one for group where the hazard ratio is 1.257. This one shows that subjects receiving treatment B have a hazard that is 25.7% higher compared to those receiving treatment A. So we are comparing treatment B versus treatment A based on our category codings here. B is being compared to treatment A. Same thing applies for sex. Based on sex, you can see that we are comparing males to females. So we would say subjects who are male have a hazard that is 22.8% higher compared to the females. And the same thing when it comes to smokers. They are the ones we are interpreting compared to non-smokers. So we would say subjects who are smokers have a hazard that is 16.3% higher than those who are non-smokers. How do we get these values? Remember, where a hazard ratio of 1 shows that there is no influence, So for any value that we get here, it is a matter of first remove that baseline hazard and then multiply by 100. That's why we remain with 25.7%. Here we remain with 22.8%, and here we have 16.3%. So that's how to interpret the outputs of Cox regression. So next we look at how do we now report the results of Cox regression. This is how you would report the results for your research output. Feel free to pause so that you can be able to read through. But you can see that in our case, since our variable of interest or our event was recovery, I'm replacing wherever we have survival with the word recovery. But if our outcomes, for example, was death, so survival would be applicable here. In our next episode, we are going to look at what if your data violated the assumptions of the Cox Proportional Hazards Model. In that case, we would use an extended Cox pH model that accommodates data which violates assumptions of Cox pH model. If you find this video helpful, consider liking and subscribing to our channel so that you don't miss out any of our future tutorials. See you in the next episode.